Are you an Oklahoma homeowner? If so, did you know that you could save hundreds on your electric bill by switching to solar? Now, the big concern is all those batteries are bad for the environment. But with home efficiency solutions, we have a groundbreaking new technology that uses a 135-gallon water tank as a thermal energy storage. That way, we can reduce the batteries that are used. So, what are you waiting for? Call Home Efficiency Solutions today and see what is possible when working with SIBS and SEAT.
This is the second semester of the tiny house project. The end goal is to create an off-the-grid tiny house that uses water as an energy storage instead of batteries, using this to also attract potential engineering students. The senior design team last semester was able to complete all the calculations, simulations, and sizing of equipment needed to start the project but could not get to the testing phase. The task this semester can be summed up by creating a proof of concept prototype that is off the grid, accurate, and automated to improve the simulations created last semester. The heating and cooling team started with sizing the new thermal energy storage tank, then became the fabrication leaders on the solar panel mounts, the new test bed, and plumbing of the system. The heat pump team was able to pipe together all the pieces of equipment with more accurate temperature sensors to improve the simulation started last semester. This piping diagram better shows what's going on in our project, with the blue being the refrigerant, the charge loop that charges the tank, and then the load loop that includes the indoor fan coil unit and the radiator. The PV team designed a solar power grid with two inverters that monitor the battery capacity and the weather conditions to efficiently run the system off the grid. The goal of the controls team was to create a user-friendly dashboard that can control and monitor the system. The dashboard shown consists of an LCD screen with interactable buttons that monitor the temperature sensors and pump speeds and report this information back to our mini PC. The main challenge the control team faced was figuring out how the system communicates with each other, controlling it, and displaying this information in a user-friendly way. The working dashboard is coded entirely in embedded C, while Python was used for data logging and sending future weather information. Home efficiency solutions accomplish the goal of creating a working prototype that gathers accurate information off the grid. There is still room to improve on this setup, but that is for future semesters to accomplish.